Okay, so Vishal, we are proceeding ahead with your mock for aerospace engineering IISc Bangalore, that is Masters for Research, right? MS Research.
Yes.
Okay, so Vishal, I will require your very brief academic introduction. So that means from where you are, when did you graduate, your BTech CGPA, GATE score, and your BTech final year project.
Okay. So my name is Vishal Shenkar. I am from Pune. I have graduated from Mechanical Engineering Department at MIT College of Engineering, Pune in 2018. After my graduation, I joined Akar Solutions, where I have experience of 2 years in structural analysis of offshore structures. And in my BE graduation, I have a 76 percentage aggregate in all the semester. And yes,
What
that's
is the
it.
GATE score?
My grade score in mechanical is 671, but I
Okay,
received this call through the XE paper, in which I got 635 score out of 1,000.
635 GATE score, and mechanical GATE score is?
671.
So you mean to say that XC may even with less gate score, the probability of getting call is high. Is that what you mean?
Yes, because sir, the IISc Bangalore has published its cutoff for the shortlisting, and for which the aerospace program, the mechanical engineering cutoff is 800, and the XC paper cutoff is 600. So that's why,
Okay, so that is the
yes,
advantage you had, right?
yes,
Okay,
yes,
what
sir.
else calls you have got so far? From where else?
Sorry, sir, I didn't get the
What
question.
other calls you have got so far, Vishal?
Cause?
Yeah, calls, other
Okay,
interview
calls.
calls. Yeah.
No, sir. This call and as well as the computational and data science department for the same program from the same institute I received. But
On
for
the
which,
basis of XC only, right?
no, on the basis of mechanical engineering. That call
That is
was on the
on.
basis of mechanical engineering.
Okay.
But I had a written test a few days back on the 11th, and I didn't clear that test. So that's why I'm not going to appear for the interview for that course.
Okay. So Vishal, what is your final year project?
Sir, my final year project was automating the vehicle assembly line using automatic washer, feeder, and retriever mechanism.
And what did you do in that?
Sir, at the assembly line in a Bajaj plant, I did my project from the Bajaj Auto, Pune.
Mhm.
So at the manufacturing plant, the worker used to collect the four washers from a tray
Mhm.
manually and then put it on the like crankcase and
Mhm.
then fix it and then it moves. So
Mhm.
one worker is there just only to put the washers and tighten the screws. So that's
Mhm.
why we automated the process using like a he will put a hand in front of our mechanism and it will directly give him four washers at a time in his hand. So that was the project.
So it looks like mass production activity.
Yes, sir. Mass production activity.
So you were working on a line, it looks like.
Yes, sir. Our aim was to reduce the production time or
Okay.
yeah.
Did you ever think of replacing human being with robots for this activity?
Yes, sir. It can be done. It has to be
It
like
can be done or
balanced.
it should be done.
It can be done. It basically depends upon how much money you are willing to put on that time. Like it's
Because
basically the balance
the
between the price and the time.
kind of activity which you told me looks like quite simple for robots. So very sophisticated robot is not required for that. Maybe very simple activity, is
Yes, sir.
can be done, and human being may be costly for that activity. What do you say?
Yes, the automation can be made even further.
Okay, Vishal, tell me, how do you relate production rate with cycle time?
Production rate with cycle time.
Cycle time, yeah.
If the cycle time is less, uh, so to say, then our production cycle will be like production rate will be higher.
What do you mean by balancing of the line?
Balancing of a line. Okay, let's say in an assembly line, there are many processes which a material has to go through in order to get to a final stage, and like each stage it consumes some time, which we refer it as a station time, and then the time required to complete the production would be like the maximum time for a particular let's say maximum time at a particular station. So if we consider that as a standard time for all, and we calculate like n multiply by this, then we will get now what say the production
Okay,
time.
let me ask you.
Yes.
If there's a line 80% balanced and there's a line which is or 90% balanced or 90% efficient, what is the difference between the two?
It means, sir, the deviation from the maximum time and the normal time is far much between the two machines.
No, but what is the disadvantage of not having 100% efficiency?
Because then the higher time, like the machines which is having the very least production time will have to wait more for the products to come at their station.
Okay, so do you think in process inventory will keep on getting accumulated?
Yes, that is one of the things that will happen. In inventory process will get accumulated.
I give you 5 stations, each taking 10 minutes.
Okay.
Tell me the production rate.
Production rate, sir, 10 minutes. Because it's a continuous process.
And what is the cycle time?
Uh,
Don't you
so
think
10
10
minutes.
is the cycle time?
10 minutes, sir.
What is the production rate now? You know, cycle time and production rate are reverse phenomena. I mean, they are related.
Okay.
1 hour production rate means in 1 hour, how many pieces are you in position to make? 10 minutes per piece. Cycle time 10 minutes means per piece is coming out after 10 minutes.
Yes.
So in 10 minutes, you are getting 1 piece.
Yes.
What is the production rate? 6 pieces per hour.
Per hour, yes, sir.
Can we say that?
Yes.
Okay, now if I give you station with the timings 12 minutes, 10 minutes, 8 minutes, 6 minutes, 4 minutes.
So 12 into 5 will be its cycle time, what we consider.
Not cycle time. Again, you're wrong. There is not a cycle time. Cycle time you have to decide. It can be 12 minutes. It cannot be less than 12 minutes.
Yes.
Minimum is 12 minutes.
12 minutes.
But why do we keep not 12 minutes? We keep it more than 12. What is the reason for that? Maximum station time is 12 minutes, but I keep it 15 minutes. What is the reason for that?
Okay, sir, apart from the time taken to this, we consider a lot of allowances, like let's say loading time, unloading time, the total time, and also the worker efficiency. So, you know,
okay,
yes.
Tell me the disadvantage of line manufacturing. What is the disadvantage? Now, one of my station gets damaged. One of my station gets disrupted. What will happen to the line production?
It will have to stop, sir.
So what should we do in such situation? I don't want my line to stop.
So we can have more recent plant layout, such as cellular manufacturing, in which it is not a line production, but the similar group of operations can be done at one section. So by using this kind of layout, we can eliminate this possibility of stopping the
Vishal,
production.
in aerospace, there are different specialization: aero
Yes.
propulsion, aerodynamics, aerostructures. Which one is your favorite? Which one you want to go for?
Yes, sir. Aerostructures.
Structures.
Yes.
Do you know what is there in aerostructures? What activities?
I have gone through its website, IISc Bangalore, and the current, like the research topic mentioned on the website was structural health monitoring, like fatigue calculation, also like stress, crack propagation, and composite materials, then the adaptive finite element techniques, etc.
So, what are your favorite subjects?
From engineering, sir?
Yes.
So strength of materials is my favorite subject. That's why the reason for opting this structures.
So tell me, you know, when we say term strength, it has got different meanings. The different kind of strengths are there.
Yes, sir.
Let me name a few: yield strength, tensile strength, fracture strength. Give me 3 more. Can you name some more?
Sir, you said yield strength,
Tensile strength, compressive strength, fracture strength.
Fracture strength. Sir, shear strength.
Okay. Just now you mentioned one of the names prior to my asking about this question.
Fatigue strength.
Yeah, tell me about that.
Sir, in fatigue stress, what happens is whenever a component is loaded at a repeatedly or reversely loaded, then it fails by appearing the crack at its outer surface, and then the crack propagates, and we get a brittle kind
Crack
of
appears
failure.
because of this, or crack propagates because of this?
Sir, I said the process like crack appears and then it propagates.
My question is, crack appears because of this cyclic loading, or
Yes,
crack
sir.
was already there?
A crack might be already there in a very microscopic level. And then due to this cyclic loading, or you can say reversely loading, the crack might get further bigger and propagate and then lead
Okay,
to a
Vishal,
fracture.
which kind of material out of ductile and brittle is more prone to such failure
Sir,
of
brittle
cyclic
material.
loading? Brittle material. Why? Do you think crack propagation is easier in brittle?
Yes, sir, because mainly in the brittle materials, the fracture occurs in the same manner as that will occur through this fatigue failure.
What if I say that getting cracks in brittle material is easier, but getting cracks propagated is easier in ductile?
Okay. If that is true, then I guess the ductile material.
My question is why this is true, but why this is true? It is easier to propagate the cracks in ductile. It is easier to get the cracks in brittle materials. And you know, this fatigue or cyclic loading does not produce crack, it propagates crack. And there's a reason cyclic loading is not good for ductile. This is the fact. Now, I want your thinking in the direction that why propagation of the cracks is easier in ductile, or getting the cracks in brittle is easier. This is somewhere related to the material science part of brittle and ductile materials.
Yes, sir. In case of brittle material, you can say that toughness is very low. So that's why the surface get easily cracked. And in case of
Is it
ductile
related
material,
to toughness or something else? Because brittleness is not related to toughness. It is related to some another property, which if we hit, you get the answer. Maybe hardness.
Hardness,
Yes.
hardness. Yes,
Yes.
sir. Hardness.
So brittle are hard.
Yes, sir. Brittle materials are hard, and that's why they get cracked easily on their surface. Yes.
So cyclic loading is not. Now, if I go to stress strain diagram, can you calculate the fatigue strength from there, from stress strain diagram?
No, sir. For for fatigue life, we generally calculate the stress cycles like the there are standard experiments from which we actually calculate the fatigue strength of a material by reversely loading it and continuously running it for some time, and we consider 10 raised to 6 cycles to be considered as a fatigue life, which is close to say let's say infinite number of cycles, and that strength what we get from that test we consider it as this
Okay,
fatigue
give some
strength.
applications where fatigue loading is tested and fatigue loading is there.
Application, sir?
Yeah, of fatigue loading.
Okay. So there are many components in which rotary parts are present and having some little bit eccentricity in the center of the mass. That is the case where it will get
bearings.
Yes, sir.
You
Bearings.
don't calculate bearings mein fatigue life. You
Yes,
calculate
sir.
that, right?
Yes, sir.
Okay, give me the example of the beam subjected to fatigue loading. Cyclic
beams.
loading.
Okay. So all the in general beams are subjected to cyclic or let's say repetitive kind of loadings because yes, sir, the loads is
in case of
continuously
static
changing.
loading, they are not subjected to this.
Yes, static loading में नहीं, but in case of dynamic loading.
मैं वही तो पूछ रहा हूँ, dynamic loading का example दो.
Yes, sir. If a machine is mounted on a floor at let's say.
What about gear mounted on the shaft?
Yes, sir.
Okay, ceiling fan.
Yes, sir.
Rod of ceiling fan. Have you seen?
Yes.
Rod of ceiling fan and ceiling fan vibrating.
Yes, sir.
No,
yes,
why
sir.
that is vibrating? Tell me. What is the reason of vibration of the shaft, I'll say, or the rod of the fan, ceiling fan? What is the reason of that?
Slightly shift in the center of mass,
Yes.
because the blades are shaped like to create the
Eccentricity.
turbulence. Yes, eccentricity.
Eccentricity.
So this is the one cause where
What
we
force
can.
acts on the eccentric load?
Sir, self-weight offset that creates.
Now calculate the force acting on the this particular body because of eccentricity. Which force? Centrifugal force.
Centrifugal. Yes, sir.
Yeah.
I was coming
So
to that.
okay, great. So tell me now one thing. What do you understand by whirling of the shaft?
Whirling of the shaft. Um,
That is also because of eccentricity, no?
yes, sir.
Hmm.
Sir, I don't actually recall the exact scientific definition for this
No, I
whirling of
don't
the shaft.
need. I need very, very basic understanding of whirling. What do you mean by whirling? That is English word, whirling. What is that?
So the axis of rotation is changing along with the having rotation on its axis.
That takes you to the chapter of vibration, where the concept of resonance you must have heard.
Yes, sir.
What is resonance?
When the natural frequency of a body meets with the external frequency, when we call that position as a resonance.
Then when that happens, what happens at that state? When natural frequency of the body matches with the external force frequency, what happens then?
Then there's this amplitude of the vibration gets like
Very
infinitely
large.
large and can cause damage to the component.
That is called whirling. Shaft starts
Okay.
vibrating violently.
Okay.
Violently vibrating. Violently means very large amplitude. That is called whirling of the shaft. Now
Okay.
tell me how to prevent that. What is done normally to prevent the whirling of shaft?
One way to do is
Yeah.
like if you increase the lateral bending, like increase the.
No. What do you do? Actually, that is the actual concept used in rotodynamics.
Okay.
You start rotating the rotor at very large speed.
Okay.
Omega becomes far more than omega norm natural.
Okay. So the
Then
problem will start in the like the beginning. If you start it and if it matches with the natural frequency, then the problem is there.
yeah, but then you increase the speed very large.
Yes.
What happens when you increase the speed to very large extent? Vibration reduces. What is the reason for that? The vibration, the frequency increases, force frequency, and it matches the natural frequency. Vibration is very large with large
Yes.
amplitude, whirling. When
Yes.
the frequency increases even further, and that because of the RPM, why very high RPM? So force frequency increases to a great extent,
Yes.
far more than natural frequency, and
Yes.
the vibration dies down. Why that is so?
No, sir, I don't know.
Because deflection, there's a expression of deflection. Then the deflection goes in opposite direction, and the eccentricity becomes zero. And the force which was because of eccentricity, that force does not exist because eccentricity becomes zero in this
Okay.
situation. The center of mass, which was at some distance away from the axis of rotation, that center of mass now matches comes on the axis of rotation.
Okay.
That is how it goes. What do you mean by this point of contraflexion in the beam? What do you mean by that?
Sir, at the point of contraflexion, the bending moment acting on that beam at that particular point is a zero. That means it shifts its sign from positive to negative or negative to positive along the
Great.
way.
So what is the significance of this point of contraflexion? Why do we calculate it?
So let's say in a beam, there are many points of contraflexures. Then we can say it's good to have many points of contraflexure because that will because the bending stress are zero at that particular points.
Do you think bending stresses are zero at that point of contraflexion?
Yes, sir. Because the bending moment is zero at that point.
So zero bending stresses, how they are helpful for us? You must have seen concrete and iron bars in the concrete, steel bars in the concrete. Have you seen
Yes, sir.
construction?
Yes, sir.
Why those steel bars are put? Why that reinforcement is given?
To give it some extra strength, like toughness.
No. Steel and concrete, how these properties are different from of these two?
Like the concrete structure is a very hard and brittle material, having the large compressive strength. And
Yes.
in case of steel, it is having more yield strength,
Yes.
and its toughness is higher, and
Yes.
ductility is higher.
Now, when you require more compressive strength, when you require more tensile strength, then you put the reinforcement of the steel.
Yes, sir.
Now, the bending moment changes its direction.
Yes.
If you go to bending equation, bending stress also changes its direction.
Yes, sir.
Right?
Yes,
Positive
sir.
to negative means compressive
Yes,
to
sir.
tensile.
So one upper layer will be like, let's say here it is positive, and after the point of contraflexure, it will have a compressive effect.
So when it shifts from compressive to tensile, I need to put reinforcement of steel. So the point of contraflexure will tell me where should I put the reinforcement of steel, because
So my question is, why the reinforcement is needed at that point? What's the need to put the steel at that point?
no, that is not steel at that point. It is only telling you in which direction it is to be put. Steel, not at exactly that point, but it is telling you now compressive strength to shear, tensile strength. So tensile strength may steel only has good tensile strength, not concrete.
Right, sir.
So stress changing from compressive to tensile, you need to change the material also to
Yes, sir.
influence the strength.
So to get the where to put exactly the reinforcement, we'll need the
Yes.
point of contraflexure. Yes, definitely.
Okay, Vishal. So I come to an end of my this mock with you related to aerospace. See, number one, you will have probability of three domains from where he might ask you a question. Number one, mathematics. So mathematics also you should prepare really nicely, because in IISc mathematics is an integral part of interviews.
Okay, sir.
Second part is your job, whatever you have done in your job related to structures that I did not ask you. So revise that very well.
Okay.
What was BTech project? He can ask you about BTech project, and then he enter into that. He might ask you the way I asked you. You should
Okay,
not
yes.
think about that. And third is related to which domain would you like to go in, aerostructures or aeropropulsion or what. So structures, when the moment you say structures, he will get into all these strength of material or material part or theory of machine part, vibration part. Vibration is very close to aerospace department, because that is
Okay.
what they are trying to stabilize the structures.
Okay.
So this is how all goes. So you prepare in these directions, right? These are
Yes,
three,
sir.
four domains for you. And in IISc, the interview pattern is little different in the sense that they will ask you to think. They will expect you to think and give answer, instead of giving accurate answer in which they may not be interested. They are interested in your approach, how you think and how you give the answers. That is what actually is important for them. So you may take time. You don't be in hurry to answer. You may take time and then you answer.
Okay.
Right. So sometimes they can give you a lot of time. Sometimes they can be rapid fire kind of interview also. Both kind of versions exist there. So that can be there. So they may not
Okay,
give
sir.
you much time also to think and ask you question after question or something like that. It
Okay.
can be there. So just prepare well for all of these things and structure. So yes, strength of material, theory of machine, engineering mechanics, which is physics part. So
Yes.
just revise these things very well. And material science also is a integral part of that. Vishal. Fine.
Yes. Yes, sir. Fine, sir.
Anything you want to ask?
Sir, based on my current answers, uh, like what rating would you give?
So I'll give you 7 out of 10, and for me 8 is very good. 8 is the rating in which you are ready for the interview, right? But I'll give you 7 out of 10 because you were faltering at some of the places where actually answers would have been easier, right? Like basic questions like fatigue I asked you, and you were not knowing about fatigue and all. The basic questions they were to be answered, like, and you were not knowing about whirling of the shaft, which is very important part of the mechanical vibration, right?
Yes,
So
yes,
to
sir.
understand mechanical vibration, you were faltering and things were not hitting your mind actually. So why this whirling of the shaft takes place? Which force is there? So it is external force acting, centrifugal force. So these are the basic questions. You see, if you don't answer the easier question, then your marks are cut. If you don't answer the difficult question, marks may not be cut. So answering the easier question is like playing a simple ball and hitting sixer.
Okay.
And difficult question is like leaving the ball so that you should not get caught or you should not get out. So that is the strategy you have to follow in the interview. So easier question comes, you should try to answer it.
Okay.
If you don't answer easier question, then your level they think is low. I mean, in that particular topic or subject. That is how you have to answer. That is the reason some marks were cut from your this entire this thing, right? The rest I think is okay.
Okay.
Right. So just prepare well, and 7 to 8 journey can be traveled simply by being good at that day. I mean, presence of mind and maintaining your concentration level. So 7 to 8 journey can be traveled in that. It may not be related to knowledge actually. If your marks are 5 or something, then it's a knowledge problem, severe knowledge problem. But because it is 7, I'm giving you, that means you have the knowledge. Only thing is things are not hitting. So how do you start hitting? Many factors are there, right? Like mock you gave and all these things. And second can be like your presence of mind and concentration level that day. So these things also matter in that. Fine.
Okay. Yes, sir.
Perfect, Vishal.
Yes, sir.
When is your interview?
It is scheduled on the 19th of May.
19th of May. Chalo, all the best for your interview.
Thank you, sir, and thank you for giving me time for having this mock interview.
See you once again. Thank you.
Yes, sir.